Hello everyone, this is Treeva pitch deck. So the problem is the railway industry. The railway industry every year takes 1.7 billion annual rail journeys just in UK, and all those journeys take energy for 1 billion, and the number of passengers are increasing every year, and the number of passengers are increasing every year. What's the problem? The problem is that, of course, the owner of the railways are responsible to ensure the safety to the customer, so passenger, train, and staff, and they need to ensure the maintenance and operation of it. So currently maintenance planning is based on fixed estimates for the expected lifespan of each piece of infrastructure. Substantial variance can be expected in these estimates under the best of circumstances. This variance is amplified by usage load, for example, number of train passing, meteorological conditions, etc. So what does it mean for the owner of the infrastructure? First of all, it is a misallocation of resources. Individual stretches of rail are mismatched with the amount of maintenance and resources they receive. In some cases, maintenance crews might be dispatched to places where they are not needed, which can waste resources as well. And in other cases, critical maintenance needs may not be recognized until they have already caused problem, which can endanger customer, and so when it is too late. So those things overall will take together inefficiencies, so decreased operational efficiency, and lower quality control, so the decreasing of operational efficacy.
Treeva's solution to this problem is twofold. One is clean energy generation, which is basically to harness the renewable energy from wind turbines, innovative wind turbines, to reduce grid dependency and also promote sustainability. And the second leg of this is the data-driven maintenance, right? So optimizing these wind turbines in collaboration with sensors and with cameras to gather essential data for optimized maintenance. Right, so the key value proposition of this is that we're able to drive energy independence and also lower the power cost for key infrastructure, railway to be specific, right, and also lowered maintenance costs for this infrastructure. And the focus of this particular solution, current focus will be on railways, but the future applications are plenty. So we have the highway, high-speed roads, the airports, seaports, all where this solution can be applied. So our target client for this particular solution currently will be the transportation infrastructure companies. So Treeva's core innovation is a miniature vertical axis wind turbine. You can see the prototype to my right, which produces power just using the turbulence created by passing transport. Right, at this speed, this is one of the most efficient miniaturized turbines with an efficiency rating of 34%, which is one of the highest in the industry. And also, the maximum power output is at 1.5 kilowatts. And uniquely, these turbines work better in close proximity as opposed to what's in the industry now, which works worse. So there are two components to our innovation. So one is wind turbine, right? This miniaturized vertical axis, which will be positioned to the railway infrastructure or any transportation infrastructure for that matter, and convert the kinetic wind into clean electricity, right? So the solution will be that we have electricity generated that can feed back into the grid and also lower the cost, lower energy cost. And secondly, we have cameras and sensors which will work to improve the operations of these turbines, but also we'll be able to collect data which we can leverage to provide predictive maintenance and optimize the operations of this infrastructure.
So to summarize, we enhance the existing technology of Treeva's of high efficiency renewable energy, integrating it with AI and expanding their data collection capabilities in order to optimize and monitor the railway maintenance operations. So if we look at the market, the railway maintenance leads to high costs and often leads to rail closures that damages greatly the ultimate customer of the railways. In terms of sustainability and renewable energy, the current competitors only achieves 12% efficacy, and in this case, Treeva is already on the 34 efficiency scope. In terms of turbines, the existing sensor are displaced in sporadically. In this case, we would have an integrated solutions for them. And for AI, we need to collaborate with AI companies and universities to optimize the prediction to accurately advise the customer. So we will need to develop a large data set and also access the data and visualize it in order to better provide advice to the customer. In terms of material, the competitors have a high waste, and in this case, Treeva is already using recycled plastic bottles. The future challenge is going to be to stress test this so that we can see how we can extend that life, and as a consequence, provide a surplus of energy for the railway company. So if we look at the envisioned business model, we're going to have, of course, on the technology side, we're going to have the suppliers of the materials and the components. And as we said, we're going to need to partner up with AI and research institutions. On the customer side, we're going to have the railway organization. It could be the private or public, which of course are going to get as value renewable energy, maintenance data, and routine maintenance, and of course advice on maintenance strategy. We're going to also need to partner up with energy storage partner in order to maximizing the effort of the two and sharing the skills. And also on the customer side, we would need to partner up to share the data as much as possible so we can know how can we most be efficient to help the customer.
In terms of technology de-risking, we have identified three major risks. From those three, we think that the risk number 3 is the most significant one, which is AI cannot be trained to predict optimum maintenance strategy. In order to minimize the risk, we tend to experiment by testing the AI to predict optimum maintenance strategy and compare it with the manual prediction. Now, in terms of marketing, we also identified three major risks. And from those three, we think risk number 3 is the most significant, which is customers are not willing to pay to optimize their maintenance strategy. In order to mitigate this risk, we think we need to create an MVP and offer it to potential customers. And in terms of ecosystem de-risking, again, three major risks, and the one that we think is the most significant is risk number 2, which is the capacity of open AI tools and technology are not sufficient to predict optimal maintenance. And in order to mitigate the risk, we think we need to research the existing similar applications of OpenAI. Now, we have calculated how much do we need to run these experiments, and we end up with 1.847 billion pounds in order to test our assumptions and their riskings. Now, this is the investment that we need. Is it worth it to invest this much in this technology? We will address next in the market size.
All right, thanks, Al. So before we get into talking about market size and aggregate, I want to quickly walk through the pricing model that's going to underlie these assumptions. So our pricing model is based on two pillars. The first is our wind turbine electricity generation business, and the second is the actual data analytics model that comes from the data collected by those wind turbines. So for the wind turbines themselves, we're selling those directly to infrastructure firms for a price of £18,000 per unit. There will also be monthly maintenance costs that get figured into that once we start getting past the first turbine. On the data analytics side, the raw data, of course, will be free to the owners of the turbines, but if they so choose, they will be able to engage us to make that data a lot more useful for a price of £5,000 per month per network. And the network is an important caveat because this will only start to make sense once clients reach a particular scale. So all of that led us to these estimates for total addressable market. So based on the total kilometers of above ground railway coverage in the United Kingdom, which is just under 16,000 kilometers, we are calculating these numbers, and this is based on the conservative estimate that we would be having one of our turbines placed every 15 meters. They can be 3 meters apart at minimum, but so this is a bit more conservative. All of that yields a total railway market in the UK of 18 billion. Doing the exact same thing on the European side, except increasing that estimate of turbines per meter to every 20 meters, we get a market of 180 billion. And it's important to note as well that this is only for railways and only for wind turbines. There are other elements of our business that have yet to come into play that will expand our market further. So just to focus on this and be a little more realistic about it, over the course of the next 5 years, we're projecting that conservatively, we should be able to get to 5% coverage across all of the UK rail networks and 1% across Europe at large. This should yield a total revenue of 3.35 billion over the course of those first 5 years. Here are some key milestones for how we're going to get there. We're assessing technical feasibility now. We would expect that we can get these things in market by 2025, and that has been our presentation. Thank you so much for listening. We'll take any questions you might have now.